Hi viewers, in today's class I am going to discuss on feed systems of parabolic reflector antenna. So basically there are four types of feed systems for parabolic reflector. Out of these four, the Cassegrain is most popularly used type of feed system. We will discuss one by one about their pros and cons also we will concentrate. So first one we are going to discuss is about focal or front feed parabolic reflector feed system. Before going to the topic, we will just have a glance on what is the feed system. So parabolic antennas are very flexible antennas. Why? Because in this, the feed system or the type of feed system we are using is having a lot of flexibility, where we have the selection according to our requirements. There are different approaches that can be adapted to meet the requirements for the given applications such as satellite TV reception, microwave link, satellite communication, etc. That means according to the practical applications, we can adapt our feed system for this parabolic reflector antennas. If the for example, here basically we have two type of antennas in parabolic reflector. One is primary antenna, the second one is called as secondary antenna. So primary means the main one which is acting as an reflector type, and the second one is called as secondary antenna. So for example, if the primary is a dipole antenna we have taken in the feed system, it will start radiate in one plane than the other. So the beam from the reflector will be somewhat flattened. So these type of cases can be avoided by using a circular horn. And in case you are going for practical application of lower frequencies, we'll be using a dipole antenna. And if you go for a case of higher frequencies, we'll be preferring the circular waveguide type of antennas. So the first type of feed systems we are going to discuss is front feed or axial feed. In this type of antenna, from the diagram, we have taken three different ways how we can arrange our feed system. So the first one is called as frontal feed. In these two cases, the type of antenna we have taken is horn antenna. And the third one we have placed is dipole feed. So in all these three cases, one point is common. That is, for all the three things, the feed system what we have placed is coincided with the axis of our antenna. That is your parabolic reflector. So it is also called as axial feed antenna. As in the three cases, the feed we are applying for the reflector is from the front end. You can see in all the cases, the feed is focused from the front end. So that's why also it is called as front feed. So in this, one main key point we have to keep in mind is the feed has located at the focus of the primary of the parabolic dish. That means nothing but, so here whatever the different ways we are placing this horn antenna, all these cases, they will be coinciding with the primary parabolic dish antenna. This type of feed always locates at the center of the dish, which is on the beam axis and at the focal point of antenna. So here, from this antenna, actually in this way, the beam will be focused onto the reflector surface. So wherever the beam focus is done, it will be coinciding with the focal point of antenna. In a simple point, if this is our reflector surface, in front feed, always the element will be placed at this position, which is nothing but we can call it as focal point, and it will be coinciding with axis. So these type of antenna feed, we call it as axial feed. But here there is a big disadvantage for this type of feed system. That is nothing but this feed will cause blocking of the radiation. That means, for example, see here, all this part of area is covered by this antenna. That means this part of area cannot be illuminated. Now, sorry, this part of area that will be illuminated can't be focused into the outer surface. Why? Because see here, this area is occupied by antenna, and after the illumination has happened, the rays will be focused like this. But here what is happening up to this area, this part of area is getting blocked. That means the aperture efficiency that we can achieve is only about 55 to 60%. So because of this reason, this front feed or axial feed is not preferred for higher frequency range of operation. And if any case, these amount of losses can be tolerated in such type of cases, this simple feed mechanism will be reflected. It can be used. So in dipole feed or horn feed or front feed, in all the cases, here a simple point is the feed mechanism is entirely dependent on axial of the parabolic reflector. Next one is Cassegrain feed. So already I said out of the 4 types, Cassegrain is mainly used for parabolic reflector antennas. So in this, what happens, we will see. So from the diagram, you can identify 2 reflector surfaces are present. This one is called main reflector. The small one, we call it as hyperboloid or subreflector. And here you can observe where the feed we have placed is at vertex point. So this is the vertex of the parabolic reflector, and here it is your focal point, right? So the horn antenna will be placed at the rear end. In the previous case where we have placed our horn in the front end, but here it is entirely different. And here the key mechanism is performed by this hyperboloid subreflector. So in this, what is happening? The feed is located at the vertex of the paraboloid and a convex shaped reflector. Keep this point in mind. The type of subreflector we have used here is of convex type of shape, and it is called as here secondary hyperboloid or subreflector, and it is always coincided with the main reflector. It is placed such that one of the foci coincides with the focus of paraboloid. That means this main reflector focal center position and this subreflector, both of them should be in a coincided manner. So here what will happen? First, from this horn antenna, the radiation will be focused. So what happens? The radio waves come in this direction. First they fall on subreflector surface. As it is it will act just like a mirror. What it does, it again reflects the rays onto this main reflector surface. So after striking this main reflector, again these waves get reflected in the forward direction. So here what is happening? All these waves that are focused are getting reflected twice. So because of this effect, what happens? Whatever all the waves exiting or coming out of from this reflector surface will be in same phase, and they get all their phase and amplitudes get added. The subreflector shaping gives amplitude and phase control of the aperture illumination. That means whatever the shape we have used for this hyperboloid subreflector, it will decide the whatever the amplitude and phase that will be occurring outside of the aperture of the antenna. So in this concept, again, we have a small disadvantage that we call it as a spillover effect, all those things. So here, however you use your small parabolic reflector, here also some amount of aperture blockage will be occurring this area, but that is tolerable amount. Compared to other type of feed mechanisms, here some of the advantages we are having is that is there is no need of long transmission lines to the feed system. So this type of mechanism is very flexible. It is often used in large antennas or antennas with complicated feeds such as satellite ground antennas and radio telescopes. The third one we are having is Gregorian feed antenna. So this Gregorian parabolic reflector antenna feed technique is almost similar to Cassegrain. But the small change we can observe here is the shape of the subreflector we have used. In previous case, already I said there we have preferred the convex mirror, but here it is the concave mirror. You can see the concave shaped subdish. You can see the change in the shape. In previous case, the subreflector is placed like this, and from horn antenna, they have focused like this. But now here, the subreflector is placed like this, and the focus will be like this. So what happens because of this type of difference is aperture efficiency levels can be achieved up to 70%. And here the Gregorian has almost similar uses just like Cassegrain. but it is not widely used because of its little bit difficulty obtaining the ellipsoidal type of shape. Compared to this, Cassegrain feed system is more popularly used. So offset feed mechanism. So this is the last case we are having. So in this offset feed mechanism, whatever the drawbacks we have seen in previous cases, that can be overcome. So in this case, what happens is this horn antenna mechanism is not in a fixed position. If you take example of horn antenna just like a shape of a torchlight, so how we focus if this is a wall or area, how the torchlight is focused here and there, in the same way the horn antenna will be moving from this end to this end of the reflector. Why we have to place like this is, for example, see in the first step, what we do, we focus this area and this area gets illuminated. Meanwhile, the rays get reflected from this surface. This horn antenna changes its position. Its position will be changed to along the axis. So at that time, it starts illuminating this part of area of the reflector. And again, meanwhile, this reflector rays exit from this center position. Again, the horn antenna changes its position towards this end to eliminate this area. So here what is happening? Whenever the rays are exiting from the reflector surface, there is no blockage or there is no aperture blocking at any of the point or position of antenna. So this is the main advantage of this offset feed system. But the difficulty is in construction and maintaining of the movement of this horn antenna. In this case, what happens is whatever the rays that are moving will be passed simply without any blockage or without any spillover effect. Here, two things we have overcome from, two problems we have overcome. One is spillover, the second one is aperture blocking. So here the advantage of using this parabolic reflector feed system is to move the feed structure of the beam path. It does not block any part of the beam. That means continuously this aperture beam will be, horn antenna will be moving from this end of reflector to this end. And the entire area of the reflector will be illuminated properly. So as we come to the end part, all the four feed systems, if you compare with each other, the first case is front end feed, where directly I said the feed system is placed in the front of the reflector, exactly coincided with the axis of antenna. The second case we have discussed is Cassegrain, where the mirror, the antenna we have used is in convex shaped, that is subreflector is convex shaped, based on the 2-time double reflection has occurred. The third case, it is Cassegrain feed, where the shape of the antenna we have used, subreflector or antenna we have used is ellipse type of shape. And here these two are almost same. The only thing or the only difference is the way how you use your subreflector surface. And mostly this Cassegrain feed is suitable for receiving antenna purpose. And this is suitable for both transmission as well as receiving purpose. And offset feed mechanism, in which the antenna is not constant in one position, it will be continuously moving over the entire surface of the reflector, right? So in this way, we can compare the four systems. Out of these four, the Cassegrain system is widely used for the parabolic reflector mechanism. Thank you.